Let me share the screen first. So what actually this is again a continuation of what we were studying in moment distribution method. And in this lecture, we would be covering further examples. First of all, let me recall what we were doing in moment distribution method. The basic formulation is that the basic formulation or principle is that the distribution of moments is done in accordance to the stiffness of the members. This is the basic formulation. Then what we did was that we we did one example already on based on this. We first of all determined in our previous lecture, we determined the stiffness ratio, and then we distributed the moments by the factor. Now that factor by which it was distributed was the distribution factor. Through this distribution factor, we distributed the moments. We distributed the moments into different members which are connected through either through joints or through supports. Now, let us take an example here. Let us take an example. Now, let us have a beam. Now, in this beam, what we have is a let this end not be fixed. Let there be a beam. Then there is a simple support here. It's a continuous beam. There is another simple support here, and there is a third simple support at this location. Now the load that's acting on this beam is a UDL load. There's a UDL load acting on this beam. It's a continuous UDL load acting on this beam. And this load is, for example, W per unit run. And there are three supports here. This is A support, this is B support, and this is C support. For example, if this length is 10 meter and this length is 7.5 meter from the other end, I expect all of you to have calculators with you. Now, when you have calculator with you, you can do the calculations. Now, what is the first step that we did in the last question on the moment distribution? Can any one of you give me an idea? What was the first step that we did? Can anyone recall what was the first step?
The fixed end moments निकाले थे हमने.
So what we actually did was that in the first step, this is step number 1, we made the ends fixed. All of the ends were clamped. They were made fixed. And once you have the end fixed, now what will be the fixed end moment here at this location? It will be W L square, W L square, right, square of L divided by 12. But it will be minus at this end. And at the other far end, you will have fixed end moment W L square by 12. So that will be the fixed end moment. Now each end of this is getting fixed. Let me draw what will happen when it's each end of this is fixed. This end is fixed, this end is fixed, and B is also fixed now. All three are fixed now. When all three are fixed, this is A fixed, B is fixed, and C is fixed here. Now, what will be the end result when you have all three fixed? Now, what will be this value here at this location? It will be minus WL square by 12. What is that? What is L for this AB section? What is L? L is 10. What is L? L is 10. So you have 10 square divided by 12 into W. So that will be 100 by 12. So what is 100 by 12? Do you have calculators with you?
So 8.33.
So that is 8.33. So this is minus 8.33. What will be the value here at end B? It will be plus WL square by 12. That's plus, it will be 8.33. But this will be into W. And this is also into W. Let me shift this a little. This is into W. This is into W. What about BC? What will be the value? Minus WL square by 12. Now, how much is that? Minus W into 7.5 into 7.5 divided by 12. Any one of you who wants to answer what?
4.687, sir.
4.687
687.
is he right? Anybody else doing the calculations?
68. Yes, sir. 750. Yes, sir. 68750.
So again, this will be into W. So now these are the fixed end moments. Now in step number 2, what do you do in moment distribution method? This was the first step. You clamped all the ends. Now in step 2, what do we do? Anybody? Anybody who wants to answer?
Applying loads.
We have already applied loads. Now, what we are doing is that there was no fixed end moment here because the ends were not fixed. So wherever there was no fixed end, we have to release the moments. Actually, all three supports A, B, and C are not fixed. They are simply supported. So after having clamped, after obtaining the fixed end moment, in the second step, we're actually releasing the moments. So at end A, how do I release moment? What is the total moment at a simple support? Anybody? Anyone? What's the total moment at a simple support? What do you get? Anyone? What's the moment at a simple support? What am I doing at these ends when I'm adding plus 8.33 at these ends?
0, sir.
Will he's right. Now at end B, what is the total moment at end B? Will it be 0? A and C will be
Sir,
0. A and C is 0 because these are simple supports, but they are the end supports. What about B? Will the moment be 0 here?
sir, it is also simply put.
It is simply supported, but will the moment be 0 here? It's continuous. It's not just simply support, it's a continuous support. At a continuous support, you do not get a 0 moment. So you are not releasing the moment at support B. So I'm only releasing the moment at support A and C, where it's confirmed that you will get a 0 moment. So that's second step. Now, what do I do in the third step? What's to be done in the third step? Just let me use the black one. In third step, can you recall what did we do last time? Any one of you? We carried over the moments. There was a carryover of moments. I discussed this last time around. What is a carryover moment? A carryover moment is once you are releasing from a simple support any moment, there is a carryover of that moment. There is a carryover of that moment to the far end support. To a simple support, there will be no carryover, but to a fixed or a continuous support, there will be a carryover. So in step number 3, I can locate the carryover. Now that carryover will happen to this end from here, and it will happen to this end from here. Now, how much is the carryover that happens to the other end when that end is fixed or continuous? Any one of you?
m/2.
Yes, it's m/2. So half of it is carried over to the other end. So that will be plus 4.165 into W. And from this end, this will be minus 2.344 or 35 into W. That's the carryover. Is the sign of the carryover same? It's same. It's because plus m/2 plus m goes to m plus m/2 and minus m goes to minus m/2. Half of it's carried over. Why is it carried over to the other end? Because once we are releasing, the some of the moment which is being released will be transferred to the other end. We studied this last time. So overall, I then add up all these moments in step number 4. I add up all these moments. Now, when I'm adding these moments, this is step number 4. this is addition of all moments. Now, what is the moment here now? Adding up minus 8.33 W plus 8.33 plus 8.33 W will be adding this and adding this one. It will give you 0. What's the moment at end C? Again, plus 4.687 W minus 4.687 W will be 0. Now, what's the moment here? Towards just the left hand side of support B, what will be the moment? Can any of you recall? Can any of you calculate this? Anyone? Plus
12.495.
12.495
Yeah.
W. This is plus. What about the other end? It's 4.687 plus 2.3435. So that's 7.0305 W. But this is in minus. So this is the carried over moment. And then we have added all the moments. But as you know, the total moment at a joint should be in equilibrium. That means the total moment at one particular joint should be 0 because that joint has to be stable. So we studied this last time, the distribution factors, which I was just mentioning at the start of this lecture. By a distribution factor, what do we mean? How did we calculate this? We calculated this last time around through stiffness factor. Now, how do we know the stiffness factor of this beam? For example, this beam has got AB portion has got a moment of inertia of I, and BC portion has got a moment of inertia of 1.55. This beam AB has moment of inertia of I and BC portion has 1.55. Now tell me, what is the stiffness of these two and what will be the distribution factor? What will be the distribution factor? How do you calculate it? We calculated it last time around. It will be, because both these beams are simply supported at one end and continuous at the other end, the distribution of AB will be 3/4 times into I by length. This is how we calculated last time, is to the distribution or the stiffness of BC, and that is 3/4 into 1.5 divided by the length of BC, which is 7.5. So distribution factor is actually the ratio of the stiffnesses of the two elements which are being connected at end B. So distribution factor will be at end B. It will be at support B. Now what will be this ratio? 3/4 into I by 10. Can you calculate it? How much is that? 3/4 into I by 10. It's 0.075 into I is to, what about the other end? 3/4 into 1.5 divided by 7.5. So it's 0.15 into I. So the total distribution, will be, now if I do 0.075 divided by 0.15, it will give me 0.5. That means the distribution is 1:2. So this is 1:2, and I are going away. This is a simple division of 0.075 by 0.15. That's giving me 1/2. So BC has got 2 times more. What I can do is I can add the distribution factors here. On this end, I'll put down the distribution factor somewhere here. This has got 2 here on this side, and this is 1 on this side, because it's 1:2, 1 for AB and 2 times that for BC. 1:2. That's how we calculate the distribution factor. So these are distribution factors at the top, which I'm mentioning at the top of this table. Now, how do I now distribute this total load? Now, our total load is this. This is our total load. This is our total moment at support B. How much is that? Can you calculate how much is the total moment at support B? 12.495 plus or minus 7.0305, which is 5.4645. Am I right? Anyone?
Yes, sir.
5.4645
Yes, sir.
plus 5.4645 into W is the total load, moment at support B. To calculate the overall moment, actual moment at support B, it has to be distributed. It has to be distributed. Now, how do we distribute it? We add a negative moment of 0.4645 W at this support and distribute that moment at support B. So thereby I have to give minus 4.4645 W at support B and distribute that moment in for side AB. The distribution will be minus 5.4645 W into 1 divided by 3, because the total distribution is 1 plus 2. So how much is this? 5.4645 divided by 3. It's 1.8215 minus 1.8215 into W. And for the other side, BC, the distribution will be minus 5.4645 into W into, on the other hand, what was the distribution factor? 2. Overall, 2 plus 1 is 3. So how much will this be? It will be minus will be 2 divided by 3 into 5.4645. So it's minus 3.645. 3.643 into W. Thereby, I have now, what I have done is that I have actually calculated the amount of moment that needs to be distributed. So this is after distributing. So this is step number 5 actually now. There is no distribution here, only because the overall moment is already 0 here at support A, and there are no 2 elements being connected at support A. At support B, where there is at least 2 elements connected, what is the AB side moment? Minus 1.8215 into W. Is this clear? Did you get this? And on BC side, how much is it? It's this, minus 3.643. Minus 3.643 into W on the other side. There is no distribution happening at support C because the moment is already 0 there and there are no 2 elements being connected. So the final picture will be again adding up these moments. We again add up these moments after distributing. Now, the moment here is 0. How do we add up? We add up between these 2 red lines and between these 2 red lines. We are not adding up from the top. We are only adding up between these 2 because one addition has already happened. Now we are internally redistributing the moments between these 2 red lines. So what's the moment here? Plus 12.495 plus 1.8215. That's minus 8215. So what are we getting is 10.6735 into W. What I've done is I've added up between the 2 red lines. Now what do I get on the other end? Adding these two, 7.0305 and 3.643. It's again a minus 10.6735 W. At support C, it's 0 between the 2 red lines. So these are the final moments. And now you can see that the support B is stable now. Overall moment, if you take out here, that will summation of moments will come out to be 0 here now. So this is the final moment. That we have obtained. Now you can go ahead with plotting these moments for ABC beam. What will that be? It will be this is the sagging side. This is the hogging side. Again, the hogging side, and then again the sagging side. So what is the moment at this point now at support B? Because it's hogging. How did you realize it's hogging? actually this by convention, this should have been A, B. At this point, it should have been negative. Then this should have been positive. Then this should be negative. Then this should be positive. If that's the convention, this means it's all in sagging. But if the convention is reverse, that means, sorry, this is sagging and this is in hogging. This is sagging and this is in hogging. Now the convention is following. So this is sagging. If this is the convention, this is sagging, this is hogging, and this is sagging. Because this point is now at 0 and this is at 0, so there is no question of sagging and hogging. This is 0. At support B, it's minus 10.67. 6735 W, and again it's 0 here. You will all rejoin in the next session.